Okay, we're going to do section 4.6, rational equations and partial fractions. Now, there's really no new notes that we need here. We're going to solve rational equations, and you should have done something like this before. Basically, a rational equation is just simply an equation that has a variable in the bottom of the fraction. So, to solve a rational equation, we simply just need to get rid of the fractions. So in our first example here, we have solve 45 equals 1700 over d minus 33. So we don't want variables in the bottom of the fraction. So we need to get rid of the variables in the bottom of the fraction. We do that by multiplying all terms in the equation by whatever is on the bottom of the fraction. Now the 45 has an understood 1 underneath it. We really don't need to focus on that because 1 times anything's that thing. But the 1700 over d minus 33, we need to get rid of the d minus 33. So we're going to multiply both sides by d minus 33. Now I've written it in blue, but we multiplied both sides by what is on the bottom, d minus 33. On the left side, we'll simply just distribute. And that is a fairly large number, 45 times 33. I'm going to go ahead and multiply that in my calculator. $14.85. Now on the left side, the d minus 33 appears on the top and on the bottom, so it gets canceled out, and all that's left is 1700. So we take the 45d, and we're going to go ahead and add the 1485 over to the other side. So 1700 plus 1485 is 3,185. And we'll divide both sides by 45 to get our d. So 3185 divided by 45. Go ahead and get a fraction also on that. So 637 over 9, or 70.778. Depending on what the application is, the exact value might be what we want, or the decimal equivalent might be what we want. But that's all you have to do. So to solve for a variable that's in the bottom of a fraction, you just got to get rid of the bottom of the fraction by multiplying both sides by what is on the bottom. Now, the last one was pretty straightforward. There was only one bottom. This next example, we have more than one bottom. So let's take a look at that. Solve a plus a squared minus 5 over a squared minus 1 equals a squared plus a plus 2 all over a plus 1. Now we need to establish what the bottoms are going to be. If there is a quadratic on the bottom, you need to try to factor it. For instance, we have a squared minus 1. That's a difference of squares. It factors to a plus 1, a minus 1. So what's really on the bottom here is a plus 1 and a minus 1. Okay, so what do we have on the bottom? Well, we have an a plus 1, an a minus 1, and an a plus 1 again. Well, we're not going to repeat anything that's on the bottom, okay, unless we have more than one of that factor underneath a single fraction. For instance, if we would have had an a plus 1 twice underneath one of these terms, then we would have to include it twice. But in this case, underneath this fraction, we simply have a plus 1 and a minus 1. And over here we have a repeat of the a plus 1. So all we're going to multiply by is the a plus 1 and the a minus 1. That should eliminate all bottoms of the fractions. So a, we're going to multiply by the a plus 1, a minus 1, plus a squared minus 5 times a plus 1 times a minus 1. Equals a squared plus a plus 2 times a plus 1 times a minus 1. Now let's say you don't get them all. You'll find that out in the next step. If you don't multiply it by enough of what's on the bottom, you'll still have a bottom. We do not want to have any bottom of the fraction. Okay, so we're going to cancel what we can. We have an a plus 1 here we can cancel, an a minus 1 we can cancel, and over here an a plus 1 that we can cancel. So all the bottoms are now 1. We don't write them, they're understood ones, but there is no more variables on the bottom. It's just ones. So let's go ahead and start multiplying these out. I'm going to go ahead and multiply the a plus 1, a minus 1 together because that's a nice little quadratic. A squared plus a minus 1. Okay, all we have left here is a squared minus 5. On the right, we have a squared plus a plus 2 times a minus 1. I'm going to go ahead and FOIL that out. So we have a cubed minus a squared plus a squared minus a plus 2a minus 2. Again, I'm taking the a squared times both of these, the a times both of these, and the 2 times both of those. Okay, let's go ahead and clean this up. So we have a squared minus 1, a squared minus 5 is hanging out. The right side we're going to clean up. We got a cubed minus a squared plus a squared goes away. We have negative a plus 2a, so that's plus a minus 2. Go ahead and distribute the a on the left side. We have a cubed minus a plus a squared minus 5. Rewriting that in order. So we got rid of the fraction. We've cleaned up both sides. We now want it to be equal to 0. We always want to get the equation equal to 0 to solve it. So I'm going to go ahead and subtract the a minus 3 to the other side. I'm going to go ahead and subtract the a to the other side, and I'm going to add a 2. So I'll show that here. So we're going to subtract a cubed. We'll do that over here. Subtract a. We must do it on the other side as well. And add 2, so plus 2. So we get a squared minus 2a minus 3 equals 0. Which is perfect, because now we have a quadratic we can attempt to solve. We can do factoring, completing the square, or quadratic formula. This looks factorable. So a plus 1 and a minus 3. Okay, the outside is a negative 3, the inside's a plus 1. That's a minus 2. FOIL it back together if you're not sure. But this definitely checks out. Set each factor equal to 0 and solve for a. So these are our two solutions. These are the solutions that we got. There's one small problem, though, when you eliminate variables off the bottom. In order to solve this, we have to do it, but the one small problem that we have when we eliminate variables off the bottom of the fraction is that some of the solutions may not work. If we go back up and look at the original, there are some values that will give us zeros on the bottom. Here, if I plug in a -1, I'll get a 0, so A can't be -1. And here, if I plug in a 1, that will give me a 0 at the bottom. So either immediately write down what restrictions you may have, and these restrictions would be things that we would have looked at before when we had vertical asymptotes, when we were graphing rationals. Okay, here we're solving, but if we were to graph this set equal to y, those would be possibly vertical asymptotes. They might be holes in the graph, but they are definitely discontinuities. A equal to 1 and -1 do not work. So if we go back down and look at our answers, A equals -1 is no longer a solution. It will give us a 0 on the bottom, which is no good. The answer to this problem is A equals 3. Now, some of the more complicated problems, if you want to confirm your answers, you can do that by, again, going back to the graphing calculator and looking at the graph. So, I'm going to scroll back up to the original. Okay, we're going to graph the original. So how do we do that? Let's go to y equals. Instead of a's, we're going to use x's. So x plus, we have x squared minus 5 divided by x squared minus 1. Notice all the parentheses that are necessary here. And I am going to go ahead and subtract over what is on the right side, because we want this equal to 0. So on top, we have x squared plus x plus 2, and on the bottom, x plus 1. And I'm setting it equal to 0. I'm going to move the a squared plus a plus 2 all over a plus 1 to the left and make sure it's equal to 0. Start with a zoom 6. Okay, now the solutions to this equation are the x-intercepts. That's what we're looking for. When you have something equal to 0, we want to know where it crosses the x-axis. So, as you can see with my cursor here on the right, the only x-intercept that I see is at about 3. Now we can calculate that by using the intersection key, second trace, number 5, intersection. Okay, so we're going to move over close to 3, hit enter 3 times, 1, 2, 3 times. And it says the intersection is x equals 3 when y equals 0. That's exactly what we're looking for. That's a solution. That's the only solution that we have. That's the only place where this graph crosses the x-axis. -1 doesn't work. If we calculate the value at -1, we get nothing. So there must be a hole in the graph at -1. Okay. Next question. Okay, similar concept. We have different bottoms. So again, we want to multiply by whatever's on the bottom. So we're going to multiply by n plus 1 and n minus 2. They're different. They're both on the bottom. We must multiply every term by those. So we're going to have 1 times n plus 1, n minus 2, plus n plus 6 times n plus 1 times n minus 2, 4 times n plus 1, n minus 2. All right, we can cancel out the n plus 1, cancel out the n minus 2. So we've eliminated the bottoms. We can start cleaning this up now. We're going to FOIL the first two here. So we have n squared minus 2n plus n minus 2. FOIL the n plus 6 and the n minus 2. So we have n squared minus 2n plus 6n minus 12. And on the right, we can distribute the 4. So 4n plus 4. All right, so we have n squared and n squared. That's 2n squared. We have a minus 2n, n minus 2n, and 6n. So we end up with negative 2 plus 1 is negative 1, minus 2 is negative 3, plus 6 is plus 3n. And then a negative 2 minus 12 is minus 14. Again, I want this to be equal to 0. So we're going to subtract 4n and subtract 4. That will give me a 0 on the right side. 2n squared minus n minus 18 equals 0. Again, we get down to a quadratic that we need to solve. Factoring would be nice, but I cannot see any way that we can use the factors of 2 and 18 and make a negative 1 by subtracting. I can't see that. So we're going to go ahead and use either completing the square or quadratic formula. I personally like completing the square a little bit better. So I'm going to use that. And the first step in completing the square is the squared term must be a plain square term. So we're going to divide everything by 2. So n squared minus 1/2 n minus 9 equals 0. Next, we will move the number over. In its place, we'll put a quantity squared. That's where we're going to complete the square. Half of the number in front of n, half of a half is a quarter. So n squared minus 1/2 n plus 1/16 equals 9 plus a 16th. It's going to be pretty big. Let's see here. 9 plus 1/16. Or if you want to type in negative 1/4 squared, that's the same thing. 145/16. Okay, so let's go ahead and factor this now. So we get n minus 1/4 times n minus 1/4. N minus 1/4 squared. Okay, we can take square root of both sides. Move the 1/4 over. Take the square root of the top and the square root of the bottom. Now, square root of 145 we should try to reduce. 145 divided by 5 is 29. 29 is prime. So 145 is prime. Okay, we can't reduce the square root of 145. So that's it. That's our solutions. Now we should write this out twice. 1/4 plus the square root of 145 over 4 n equals 1/4 minus the square root of 145 over 4. And we need to get the decimal equivalents. Again, what application is this going to apply to? Not sure at this point in time. But we probably will need the decimal. Decimal answers are probably the more important. So let's get equivalent decimals. 1/4 plus square root 145 divided by 4. And minus. So we end up with 3.260 and negative 2.760. These are the exact answers. These are the decimal answers. The application will tell us which of these we would want to know. The decimal answers we can confirm. After doing all this work, we can check to see if we got it right. Again, by graphing. Let's go ahead up and look at the original problem. We're going to go to y equals. Type it in. 1 plus x plus 6 divided by x plus 1. Again, we have to use x instead of n. And again, I'm going to subtract over. The 4 divided by n minus 2, or in this case, x plus 2. I'm sorry, 4 over x minus 2. We want it to be equal to 0. That allows us to graph it and look for x-intercepts. Zoom 6. Okay, it's an interesting looking graph. The part that we're interested in is right here, where the x-intercept is. Looks like about negative 3. And right here on the right. And it looks to be about a little bit more than positive 3. So let's calculate it. Second trace, which is the calculate menu, number 5, intersection. Get close to intersection, hit enter 3 times. There's negative 2.760, exactly what we have. And calculate the other intersection. Okay. Oops. That, guess we could put in the output 3. Okay, 3.260. You don't have to put in a guess. I must have hit the wrong button there. But we get the other decimal, 3.260. The calculator will not give us exact. If we need exact answers, we must do it with algebra. Again, we can check to see which ones would work and which ones wouldn't work. If we go back up to the original, what wouldn't work here is n cannot be negative 1. Does that would give us a 0 or 2? Negative 1 and 2 would not work. Neither of those are affected by our solution. We didn't get negative 1 or 2 for the solution, so all of our solutions work here. Both answers are correct. Okay, last example. Partial fractions. Now, this is an interesting concept. Basically, we're going to decompose a fraction. We have a single fraction here, and this is used in higher level math. It's something you definitely need to know how to do. For sure, I know I saw it in either Calc 1 or Calc 2. This is the basics of it. Right? So basically, we want to tear this fraction apart. Okay, that's the idea here. We want to tear the fraction apart. We currently have one fraction. We want to make it 2. So how do we do that? We first look at the bottom, and we decide, can we factor the bottom? And it does look like it's factorable. Looks like we got x plus 2 and x minus 1. So we can say the original problem is equal to two fractions. What we're going to do is we're just going to write the two factors that we got separated. And on top, an A and a B. So notice the fraction that we had, that we factored, has two factors on the bottom. Okay? Each factor was written under its own fraction. Now we're going to try to find a value for A, some number A, and some number B that makes this equation true. So all we got to do is solve this, just like we solved the last one. Okay? Like we solved any problems that we've done today. We're going to multiply by what's on the bottom. So we're going to multiply everything by x plus 2 and x minus 1. So 8x plus 7 times x plus 2, x minus 1, equals A times x plus 2, x minus 1, plus B times x plus 2 and x minus 1. And we're going to cancel out whatever we can cancel. So we end up with 8x plus 7 equals A times x minus 1 plus B times x plus 2. So it's very similar to what we did when we solved earlier. We had to multiply by what was on the bottom. Okay, the difference is setting it up. Okay, in order to set it up again, we had to factor the bottom. We're going to set each factor under its own fraction and figure out what value will go with that. So how do we figure out the value? It's very simple. We're going to plug in an x value. We want the x value to eliminate one of the variables. In other words, what can I plug in here to make this 0? And the answer is 1. And then we'll do it again with what can we plug in here to make that 0. And that answer is negative 2. So we'll start by saying x equals 1. Well, if x equals 1, what's my problem going to be? Well, let's see here. 8 times 1 plus 7 equals A times 1 minus 1 plus B times 1 plus 2. Well, 8 times 1 is 8. 8 plus 7 is 15. Well, A times 0 is 0. That's gone. Then we have a 3B. So, solving for B, divide both sides by 3. We get 5 equals B. Very good. So we know what B is. We'll do the same thing with x equals negative 2. So we go back up here. Okay, this is another problem. Go back up here to 8 times negative 2 plus 7 equals A times negative 2 minus 1 plus B times negative 2 plus 2. This is negative 16. Negative 16 plus 7. Negative 9. This is negative 3A. And B times 0 is 0. So divide both by negative 3. We get 3 equals A. So what is our partial fraction? We go back up to the original. It says A over x plus 2. So I'm going to write down the original. 8x plus 7 over x squared plus x minus 2 is equal to, basically it was A over x plus 2 plus b over x minus 1. Double check that one more time. Yep. So what's A? A is 3. And B, I believe, was 5. Let's check here. B was 5. So there's your answer. All you do is plug in the A and B back in, and we have decomposed the fraction. We took a single fraction and broke it up into 2. Again, it's a very helpful concept when we get to the higher level maths. So that's it. That's all I have for today.